Hello everyone, and welcome back to a kind of video I haven't done in a whole while. Today we're taking a look at a broken graphics card. So this right here is a already disassembled RX 570 that is a very interesting OEM model because like the heatsink it comes with is so nondescript you would be able to mistake this as an Nvidia card because this is literally the exact same shroud that Nvidia shipped with like its OEM GTX 660s and 760s and stuff like that, just with a cooler that fits an AMD card. And the even more interesting part is, this is not a reference PCB. This is a custom PCB I've seen nowhere else before. So yeah, this 8GB RX 570 actually has a full 6-phase VRM. Which I didn't know I was gonna get. I expected a reference PCB, and this is probably on par with the reference PCB when it comes to the VRM, but this layout is like much nicer than the actual reference PCB, so mounting a custom VRM heatsink on this is probably way easier. Yeah. Now I need to tell you a secret right here. I did already troubleshoot this card. I already had a video recorded with this, but I didn't like the take, so I'm reshooting it. So I'm gonna potentially pretend I don't know certain things that I actually do know, just for this video to be a bit more organic. But yeah, so this here, RX 570, is now going to get my usual troubleshooting treatment, as I give to every card. And let's start with that. So we get our multimeter, and as always, the first thing we're testing is we are testing for continuity on the 12 volt and 3.3 volt inputs, because if we get continuity on any of these, that's a big short circuit. So ground probe goes to somewhere that has ground, and let's test PCIe 12 volts. That's fine. PCIe 3.3 volts, that's 1, 2, that's also fine. And then the 8-pin, which, how do I actually get? They're the best, probably just here. That's also fine. So we have no major short circuit on any of the inputs, which is good, which I totally didn't know beforehand. So let's switch over to resistance mode and see if anything weird can be seen on the VRM outputs. So let's first check this little thing here. I'm not entirely sure what this is. It might be PEX. It might be... for 1.8 volts, this is too low resistance. It's probably PEX. Yeah, 12.6 ohms. That's fine. Then we're going to check our VCore VRM. That's these 6 lower phases here. And then we have a memory and a VDDCI VRM, which I'm not entirely sure which is which. I wanna say the upper one is probably VDDCI, because that should draw more power than the memory and the memory only has 2, this has 3. But the resistance might give us a better idea of what it actually is. So let's first try the core. That is a fairly low resistance. That is actually pretty close to what you get when it is actually short. Like, this would be an actual short, because there's a little bit of probe resistance. But this is fine, because this is a... Actually, it's the 16 nanometer. I think this is a 16 nanometer GPU. Very low resistance. So this is fine. A lot of people freak out when they see their core resistance this low and then go like, oh no, my core's short circuit. It's not. It's fine. It is fine. Like, usually the only kind of short circuit that usually appears in connection with the core is a short circuit from 12 volts to the core, which would show up as a very low resistance like this, but on the 12 volt line, not the output of the core. Because this just is the resistance of the core, it just has that low of a resistance. So this is perfectly fine. Now let's try the small VRM number 1. What do we get here? 22 ohms, yeah, that sounds like memory. That is what I would expect from a memory VRM, so this is also fine. And let's check what this is, probably VDDCI then. Yep. So a little lower, like between the core and the memory in resistance terms. 16 ohms, also completely fine. So our main big VRMs are fine, PEX is also fine. We have, maybe a little bit more here. We have what's probably a 5 volt LDO, let's see. So we get quite a lot of resistance on that one, like that's probably the output then. Yeah, like 8 kilo ohms. That is 6 kilo ohms. The middle is then probably ground. Yeah, that's ground. Let's check which is 12 volts. If it even is connected to 12 volts. Okay, that's 12 volts. So the upper one is the output then. And that has several kilo ohms, so that's fine. Is there anything else? We probably have a 1.8 volts array, which is probably one of these two chips. One is going to be the BIOS chip. The other one is going to be 1.8 volts. I am not entirely sure which is which. It's probably this one, because that's a UP something. That part number looks more to me like a converter than that. That's probably the BIOS chip then. I don't actually know, like, I would need to look at the datasheet to find the output pin of this. But, like, if this was... Yeah, there could theoretically be a short circuit at the output of the 1.8 volts BRM. But that's not really gonna be an issue if there's a short circuit on the output of this. This is just gonna not run. And we know there's no short circuit on the input because all the 12 volt lines read correctly. So, I don't know where to measure this yet. If we turn the card on and see every other voltage running but still not get an image, then I'm going to get the datasheet and measure this. But if we get an image, or like if we see something else have obvious problems, then we can just forego this. So it's not that important that we can't measure this right now. It's 1.8 volts is a very, very low current rail. So these kind of just can't really cause any fires if they're short circuit, because this delivers like maybe 1 amp. And this thing is just gonna shut down if anything pulls more than 1 amp. So yeah, that should be all the major rails. That's 12 volt input. The 8 pin doesn't have an input filtering inductor, I just noticed. But yeah, so resistance wise, the card checks out. One thing that you might notice in the visual inspection is there's some goop around these two memory modules. Now, that looks like someone messed around with these modules before, which does not bode well for the card. The card was described as no image. Now, no image usually means one of the VRMs isn't running, because you know, if you have a problem with like silicon, like the memory chips or the GPU core itself, usually you still get an image, or at least you get a video signal. The image might just be a black screen, but your monitor will detect a video signal and will turn on the backlight. You usually get at least that, or just an artifacting image if you have a like a silicon problem. And when you get a total black screen and no signal at all, then that's usually a VRM not running issue. So because this one was described as no signal, and we now see someone messed with the memory chips, not a good indicator. Now this could just be underfill. These two memory chips are the closest to the PCI Express slot, and on some cards you see underfill under the chips near to the PCI Express slot, and also the GPU sometimes, because underfill helps keep the chips in place when the PCB bends from GPU sag or during transport, and that's just to make the card live a little longer, because like it's especially a big issue with big heavy cards that have big heavy heat sinks and cards that run very hot, is because due to thermal expansion and GPU sag and all that other stuff, the PCB bends. And when the PCB bends over time, it slowly destroys the BGA, the ball grid array below the memory chips and the GPU core, which is why you have this underfill glue sometimes in areas that are especially prone to bending, like this line right here, because the card will be fixed in these 3 points, and this is just sort of free hanging, and sometimes the cable even drags it down. So you tend to have the strongest bends around here. So you see some GPUs like reinforced memory chips, and sometimes the GPU in that area. So this might just be underfill. But yeah, so card is described as no image. So technically we should not have to worry about this, because you know, it's described as no image. So we should expect one of the VRMs to not run, or just one of the video outputs to be that. That would be like the best case if just one of the outputs is dead. One of my GTX 760 OEMs is like that. It just has a dead HDMI port, but the other ports work just fine, and it seems that the seller only tested the HDMI port. And we have, well, we have a display port, an HDMI, and a DVI on this, so if one of them is dead, that's not a problem. But yeah, so let's reassemble the card. I'm confident enough to turn it on now. And, well, we won't be able to measure the PEX rail because it's on the front, but everything else, voltage-wise, can be measured on the back. Actually, there might even be... Well, this little chip right here also generates the PEX rail. One of the capacitors might be able to be probed to check the PEX voltage. But yeah, so I'm gonna reassemble the card now, then turn it on, and we're gonna see what runs, what doesn't run, or what more clues we can get here about what's wrong with the card. Before we continue on, let's welcome back our returning sponsor, PCBWay. PCBWay is a great supplier for getting PCB prototypes made and quickly shipped to your door. The ordering process is simple. Just select and fill in your PCB's parameters, click calculate and then save to cart, then fill in your recipient information and finish off by choosing your payment method and shipping option. PCBWay also offers PCB assembly services as well as more advanced options like flexible and more complex PCB manufacturing should your project have a more ambitious scope. If you have manufacturing needs that don't involve circuit boards, you will also find options here, as PCBWay also offers CNC and 3D printing services, as well as the option to build an assembly stencil for your project. Alright, we have the card installed in my test bench system now, and let's turn the entire thing on. Okay, we don't immediately have a fan spin, but it might turn on any second now. Okay, there we go. And let's check the postcodes. We have a B4, we have a VJ LED, and is there an image? Screen's detecting something. There's a blue LED. Oh, yeah. Alright, we have an image. However, I'm not happy. Because this is a very, very strong and pretty much almost certain indication that this card has a dead memory chip, or even memory controller channel. So, card's not as described. Case closed? Well, no. Here comes the part where I already recorded this before. So, this card was described as no image, and it very clearly has a broken memory chip. Also, please excuse the very messy desk. So, yeah, artifacting like that. By the position of where the artifacting is, you can even also determine which channel it is. And yes, it is the channel with the two modules that are slightly messed up. So there was an attempt to already probably reflow the modules. I hope it wasn't done with a heat gun. The presence of what we can now assume is flux residue around the chips implies that it was done with a hot air station, so I guess that's okay. But apparently the reflow didn't work, which leaves us with one of two possibilities as to the fate of the card. Possibility one is one of the memory chips is just completely dead, or there is some very strong damage to the BGA that just can't be fixed by melting the BGA and then hoping that it reconnects. Possibility number two is the problem is the memory controller of the GPU, which has a dead channel, which means that this is a no-fix. If the problem is with the GPU, this is a no-fix, because to fix a problem like that, we need to replace the GPU, and getting a new functional GPU for a card like this that is a couple years old now and pretty cheap to find secondhand is just not economical, because you're going to pay basically as much as a new card costs for that GPU core alone, and then there's also the part where you need to swap it out, which I can't do. I need a dedicated reball machine for a big chip like that. So yeah, so if it's a GPU problem, then that's the end of the story, and this card probably is becoming an e-power. But if it's the memory chip, there is a chance that this can still be fixed. The problem is I can't fix it today because this card is using Samsung 8 gigabit GDDR5 chips, and I just don't have any of those here. And I would also need to buy new ones, which is also still quite expensive. And if it then turns out to be a GPU issue, then I spend a lot of money on a card that can't be fixed and now have memory modules that I don't need. So, yeah, ultimately what I'm going to do with this card, I'm putting it onto the pile of the cards that possibly need memory modules swapped. And if I can ever find cheap memory modules that fit the card, or get another card that has very obvious like core damage and the memory modules are fine that has the same modules, then I'll try to swap it out. I do have some BGA solder balls and a little stencil holder now, so I will try to start swapping out memory modules, not on this card, but cards where I just have replacement chips from known dead core cards. So yeah, so this card might still live one day, or it might become an E-Power, which is sadly the end of the video in the general way. So this is a diagnosis. My diagnosis is either a memory chip or GPU memory controller issue. I can't fix that today. One of them is unfixable and the other one is very far future fixable. But I think I want to say one more thing. So the seller that said that this card puts out no image might not actually be lying. Because, you know, selling this as the card doesn't put out an image, that's pretty misleading. So, yeah. And also, why would someone lie about a broken card that they're selling for? Like, I didn't pay a lot for this. This was an extremely cheap broken card. So why would someone lie about the state of a broken card? Maybe they know enough about repair to know that it's more likely to be bought if it's just a no image rather than an artifacting one. But don't attribute to malice what you can attribute to a lack of knowledge. And there may be a different way. So we're going to shut this system down real quick. And then I'm going to replace this DVI HDMI connector with a DisplayPort connector. Because from what I've seen, using DisplayPort connected into the same monitor, it's just not going through the capture card now, it's just directly connected. This now probably is still going to boot. Like, we have a B2. It's figuring its thing out right now. It does actually seem to be kind of stuck on B2, which is interesting. But yeah, from what I've seen, if you use DisplayPort on a card like this, you sometimes don't get an image. And, well, right now we're not getting an image because the card is actually stuck on B2. Let's see if that's consistent or if that was just a fluke. It does actually seem to be stuck. Okay, I didn't actually pay attention the last time I tested this, but yeah, you just saw the card boot and put out an image, and now we've swapped to DisplayPort and it's stuck. It won't post, and there is no signal. We have an orange LED, no signal. So what I think happened is the seller was using the card with DisplayPort and didn't bother to check the other outputs, and there just has to be something in the DisplayPort protocol that just prevents the card from putting out an image, or booting in this case. That, like, maybe there's some handshaking that needs to go on, and because of the memory errors that this card had, it's not happening correctly and it gets stuck posting. So that's what I think happened to the seller. The seller was just using DisplayPort and suddenly the card didn't put out an image anymore, and they sold it as that, and I, not knowing that that's a possibility, picked the card up expecting to just have like a VCOR VRM that's not firing up. But as it turns out, not the case. So yeah, so if you have a card that's not putting out an image and you're using DisplayPort, it's worth to check the other outputs as well. to see if it might not actually just be an artifacting card that just has a problem with DisplayPort. Like, DisplayPort in general is it's a good standard for enabling, you know, the bandwidth that the other standards can't, but it is a very, very janky standard. Like, I don't particularly like using DisplayPort, and this is one of the reasons. So, yeah, that's gonna be the actual end of the video now. So, sadly, another one for the pile that potentially needs memory replaced. Yeah, I mean, I have the stuff now to swap memory chips. I just need to start doing it. I have a couple other cards where I actually have memory chips that are compatible that I can swap out. I'm gonna get into that in the somewhat close future, so maybe I'll actually start repairing some of the cards from that pile or finding out if the core is just dead. So I guess stay tuned for that. There might be some more repair content on the channel, but I gotta be honest, I am sort of running out of storage space for more GPUs. So I tend to only really buy dead GPUs when I find them either extraordinarily cheap or they are like a GPU where I go like, I could actually use this card and I can probably fix it. This was one of them where I went like, I could actually use this and can probably fix it. Because I originally planned to put this card into a PC at my parents' place, which had a 780 Ti in it, which was literally like 1 amp from overdrawing the power supply in that PC, so I wanted something that's about the same speed but way more power efficient like this. But turns out yeah, my gamble didn't pay off, and the card is actually not that easy to fix as I expected. Anyway, so that would be it for this video. So thank you for watching, and until next time, goodbye.